Welcome back, class. Today we are going to discuss silicates. Silicates is the topic of carbon family, and this is the lecture number 4 for the carbon family, and probably the last topic of the carbon family members. Mainly in examination, silicates questions are comes in structure format, like they can ask the structure of the silicates or the formula, the basic you need it. So first we'll start the definition. What is the definition of silicates? So silicates are minerals actually. Silicates are minerals which contain silicon and oxygen atom. So the basic unit is SiO4 4 negative. This is what the tetrahedral. Okay. Now on the basis of this basic unit, we can classify silicates in different types, and which is the important one. Okay, so the classification of silicates is based on this basic unit, that how this basic unit is available in that particular silicate, whether it is in n number, whether it is in cyclic form, whether it is in linear form, whether it is in three-dimensional form. So these basic unit is actually the backbone for different silicates. Okay, so starting with the classification of silicates. So the very first is orthosilicate. Orthosilicate is also known as nesosilicate. Neso. Okay, so in orthosilicate, this is the fundamental, very fundamental. So SiO4 4 negative is the basic unit in this case. So how the structure will draw? Si, then we have 4 oxygen atom like this. Okay, so this is how they combine, 4 negative charge. This is what the SiO4 look like in tetrahedral geometry. And now the 2D structure, how the 2D structure will draw. So the 2D structure will draw like this. And these are the oxygen atom. Okay, and the smallest one, this is the silicon. Okay, so this is how the, and the negative charge is showing that the fourth atom, which is in the tetrahedral structure, the fourth atom is of this. So this is negative charge, this is negative charge, this is. So this is the 2D structure of SiO4, the orthosilicate. Okay. One more thing I would like to inform you here is that how you will find out the charge on that particular silicate. Like in this case, we have 4 negative charge. Okay, so how this 4 negative charge arise? So no need to remember this. Only that what is the valency of silicon? +4. And what is the valency of oxygen? -2. So this will be -8. So this will give you -4. So the charge will be -4. Okay, so no need to remember this. You can easily find out. And example, if we go for the example of this particular silicate, so zircon is the example of this. The formula is ZrSiO4. Got it? So this is how the first silicate is complete. Now move on to the second one. The second is pyrosilicate. Pyrosilicate. The other name of pyrosilicate is I will give you in short. So pyrosilicate. Okay, pyrosilicate is that silicate in which two molecules of orthosilicate is involved. So the combination of two molecule of orthosilicate. Okay, so the two Si, one oxygen, another oxygen, and this oxygen is combined with another silicon. So this will be this oxygen, and this oxygen. So this is the negative charge. Okay, so here the Si2O7, one oxygen will be skip out while adding with these two molecules. So Si27, and what is the charge on this? We can easily identify it. +4 for silicon, so this will give +8. -2 for oxygen, so this will give -16. So this will give -6. The charge on the pyrosilicate is 6 minus. Okay, so uh, how the 2D structure will draw? The 2D structure of this silicate. So 2D structure, we will draw the 2D structure for you. See, the 2D structure may look like this. This is 1, 2, and 3. Okay, and 1, 2, and 3, and this is the smallest atom. So this is a silicon. No? Small one is a silicon, and this is how. Okay, I forgot one thing here in this structure. Here is also you need to write like this. Okay, so this is what the 2D structure of pyroxene. Okay, okay, these all are the negative charges oxygen. An example, if you go for the example, beryl, the example in this case is throat white. Okay, Sc2 Si2O7. Sometime question may ask from the example part also, so you should remember at least one example. Okay, okay, moving ahead, next we will talk about the third type, and that is the ring silicate. Ring silicate. Okay, so ring silicate, another name is cyclic silicate. So the basic unit in this case is SiO3 whole n 2n negative. Sorry, 2n negative. Okay, so you can easily identify that how this Si is +4, oxygen is -2, so this will give -2, so that's -2, and n is for number of unit, how many number of ring is there. It can be 3, it can be 4, it can be 5, it can be any number. For example, if you talk about n is equals to 5. Okay, so if n equals to 5, then what will happen? SiO3 5, and for 2n it will be -10 minus. So Si 5 and O 15, 10 minus. So this is how the ring silicate, the basic unit. Now what is the structure of ring silicate? So structure will give, this is one oxygen, this is another oxygen. Okay, and with this we can go for two oxygen, so this will combine with this two, and this oxygen and this oxygen will give you the third one. Okay, and then we will put the silicon in between this one unit. Okay, so this is how the ring structure is drawn. Now one important point here in case of ring structure, ring silicate, each unit share two oxygen atom with other unit. Each unit share two oxygen atom with other unit. This you should remember. Okay, so like in this case you can see that this is a unit, so these two oxygen is shared by this oxygen is shared by this unit, and this oxygen is shared by this unit. Okay, similarly this oxygen is shared by this unit, and this oxygen is also shared by this unit, so each unit is sharing like this. So this is how you can remember. So these are the three different types of silicates: orthosilicate, which is also called mesosilicate, pyrosilicate. Actually I forget the name, other name of this pyrosilicate. And then we have a ring silicate, that is also called cyclic silicate. Okay, so this is the three types. Next we will talk the fourth one. Okay, so next is the type of silicate is called chain silicate. Chain silicate, other name is pyroxene. Pyroxene. So as the name says, the pyroxene or the chain silicate, that means we have n number of chain. So the number of tetrahedral unit combine linearly. Important is that linearly, you should combine linearly. Okay, so it can be any number, and the basic formula is SiO4 4 negative, because the tetrahedral is combining, so the basic formula is the same, and it can be for any number. Okay, like it can be for 4 number, 5 number, 6 number, it can be for any number. So here each unit shares two oxygen atom with other unit, but different is what? Linear. Okay, so how the structure we will draw? So just put a line, linear line, 1 2 3 4 and 5. One oxygen here, another oxygen is here, another oxygen here, here. Okay, then combine this one. Then we'll go for the silicon. So this is the simple. Okay, so this oxygen atom is shared by this unit also and this unit also. Okay, this oxygen is shared by this unit also and this unit also, so each unit share two oxygen atom with other unit. linearly. The important thing is what? Linearly. Okay. Okay, so next we can take example also for chain. Example is spodumene. This is a lithium aluminum complex actually. Si. No, this is not correct. Okay, so next we'll talk about the next that is the fifth one, and this is the double chain. Double chain. And the double chain example is, sorry, the double chain another name is amphiboles. Okay, so you should remember the other name also. Sometimes the question should ask, sometimes the question may ask from this also. So double chain basic unit is Si4O11 and 6N negative. You can identify the valency. Si is plus 2 plus 4, so this will be plus 16, this is minus 22, this will be minus 6, this minus 6 is here. Okay, so here same thing, each unit will combine with the other two unit again. No and the example of this is asbestos. Asbestos is the example of double chain. Okay, so how the structure will draw? So structure, for structure will go for this one, then two. No, nothing will do. One chain is here already, we know that, so we'll put the two chain. 1 2 3 4 and the fifth one. 1 2 3 4 and the fifth one. Then put one oxygen here, 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 one oxygen here. Then we will combine this. So now we'll put the silicon. Okay, so this is how this oxygen is present in both chain. This chain is also and this chain is also. So this is how the double chain is formed. The basic unit is Si4O11 and the example is asbestos. Okay, then we move for, these all are 2D structure. Okay, then we move for the sixth one, and that is the sheet silicate. Sheet silicate. The sixth one is the sheet silicate. So the sheet silicate, another name is phyllosilicate. Phy phyllosilicate. So here what will happen? Here 3 oxygen atom will be shared. 3 oxygen atom will shared. Okay, so we'll draw the structure, the 3D the sheet silicate structure. So here we I'm putting one line, then the second line, then the third line, sheet line. So the sheet silicate is also called silicate, and the structure of sheet silicate is look like this: one oxygen, then one oxygen, then here we will put one oxygen, then one oxygen here. Okay, then we'll draw a structure. This will draw like this. Then this can be extend further, no, this can be extend further also. So here is the silicon. The simplest the formula, the simplest unit in this case is Si2O5, Si2O5 2 and negative. Okay, so this you can identify, as I already told you that this is plus 4, so this will be plus 8, then minus 10 for oxygen, so this will be minus 2. Okay, and the example of this silicate is mica, a well-known example. Talc is there, and here what is the important thing to remember, that 3 oxygen atom is shared. 3 oxygen atom is shared. Okay, so this is sheet silicate, and the last one is 3D structure, three-dimensional silicate. So the seventh is the three-dimensional silicate, which is also called silicate. So as it is three-dimensional structure, so it is not possible to draw the structure here. The basic unit is SiO2 whole twice and N. Okay, and the example is quartz. Now, so far we had studied discussed the 7 type of silicates. Now one thing is that it is very difficult to remember the formula of all silicates, because we have 7 types of silicates. So it's really difficult to remember all that. So I have a idea for that, and you can, with the help of this, you can easily identify the formula. So what is that? See, take revision of s p d orbital. Okay, this is very simple, you can easily remember this. Now what take will see T and C, take for T and C. This is revision, R for revision, O for off, S, P and D is as it is. So what T represent here? T represent the tecto. What C represent is chain. Okay, what R represent is ring. Then O say ortho. S is sheet, pyro, and double chain. Okay, then the silicon and oxygen atom. So how the silicon and oxygen will write? So for siliconation we start with this, the double silicate. Here we have 4. Okay, 4 for this double silicate. Then 2 is the sum of 4, 2 and 2. Then 1 1 1 and 1, sum of 4 is 1 1 1 and 2 2 2. Okay, then for oxygen, the first will write the 2, 2 and 1 is 3. Then here R is the revision, R is the revision, so I'll revise, that is 3 again. Then 3 and 1 is 4, 4 1 and 1 is 5, 5 and 2 is 7, 7 4 and 11. Here something you should remember. Okay, so this is how you can find out the number of silicon and oxygen atom. Now we'll check it out. We'll check the first one, that is the 3D. We'll check, that is the tectosilicate. So what tectosilicate, tecto, that means one Si and one oxygen, sorry, two oxygen. So this will like this, tecto. Then you can take anyone. uh, you can take the example of pyro. So for pyro you can see here the Si is 2 and oxygen is 7. Okay, so this is the example of pyrosilicate. Then we have chain. We can take example of chain silicate. So for chain silicate we have Si1 and oxygen is 3. So here I made the wrong, this is wrong actually, no, chain is Si3. So if it is SiO3, what is the valency over there? Plus 4 minus 6, this will be minus 2. Okay, so this is how you will remember all the silicates. And I had discussed all the silicates with their structural representation, their formula, and the way to remember that silicates. So this is how, and thank you so much for watching.